Okay, so here we start to look at fractions and the two different forms a fraction can take. So hopefully we've seen before that it can come as either a mixed fraction or as a top-heavy fraction. What does each of them mean? So the first one here is a mixed fraction, and it consists of a whole number and a fraction beside it. So here it tells me that I've got 2 whole and 3 quarters. So we think about what that is as a picture. I've got one shape, I've got 2 whole shapes, and then I've got 3 quarters of another one. So I'm going to split my shape there into quarters, and I just want 3 of them. Okay, and so for consistency, I could split these ones up into little bits as well, but I want the whole, so I want all 4 bits. Okay, that's then what I've got here. Top heavy fraction is named because the number at the top is bigger than the thing on the bottom. Okay, so both of these names hopefully self-explanatory. What do I have here? I've got 11 quarters. And so again, if we think about what we've got, we're going to draw out 11 quarters. So there's 1, 2, 3, 4 of them. Another whole shape split into 4 quarters. So 5, 6, 7, there's 8, 9, 10, 11. Okay, and so we can see from our picture that we end up getting the same amount of stuff. And so those two fractions are worth the same amount, just written in different forms. Okay, so we need to be aware of them, and we need to be able to identify the differences. We also need to be able to convert between the types. So, looking at what we've got here, first one we've got is 3 whole and 2/3. So again, if we think about what we've got in terms of our picture, we start to draw it out, and we can split it in any way that we want, and people tend to draw circles. Okay, people tend to go, oh, right, I've got one whole, and then we start trying to split it into thirds. Okay, they're not too difficult to do, but if we were to look ahead to the next one and try and split the circle into 5 sections, that becomes a really difficult thing to do, and then they don't all get to be the same. It becomes quite challenging. So we tend to not try and use circles if we can, and we use some kind of square or rectangle shape. So let's make it a little bit more rectangular. And we're going to split it into thirds because that's how many we're going to deal with, but I need 3 whole to start with. So there are my 3. And I need 2/3. So shade them in. 1, 2. So here, when I want to be a top heavy fraction, I want to know how many thirds I've got. Well, I've got 3 in the first one. I've got 3 in the next one. I've got 3 in the next one, and I've got 2 down the bottom. 3, 6, 9, 11. So I end up getting 11 thirds here. Next one. We've got 4 whole and 2/5. So again, we're going to think about the same thing. So I've got 1, 2, 3, 4. But the fraction I'm dealing with this time is fifths, and so I need to cut my shape up into 5 bits. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so I need all 5 of them there. I've got all 5 of them here. All 5 of them here. All 5 of them there, remember, because we wanted 4 whole shapes and 2/5. So I've got 4 whole shapes and 2/5. How many does that give me altogether? 5, 10, 15, 20. That gives me 22 over 5. Now, an alternative way that we could go about doing it, we don't want to have to draw out the shapes every single time. We can cheat a little bit. And what we can do is, if we've got, back to the first example here, I've got 3 and 2/3. Well, what we can do is we can take these two numbers, we can multiply them together. Because for each whole, I'm going to split it into 3 parts. And I've got 3 of them. I've got 3 whole. So I'm going to have 3 lots of 3. And between this bit here, I did end up getting 9. After that, I want to add on these extra 2 bits. that I've got. So what I should end up getting then, 9 plus 2 is 11 bits. And how big were my bits? They were thirds. So again, thinking about the second example, we had 4 and 2/5. And so I've got 4 holes and they're cut into 5 bits each. So 4 times 5 is going to give me 20 bits. And then I need to add on the extra bit missing from my shape. Add on 2, and that leaves me with 22 bits. And what size were the bits? They were fifths. So I need to make sure I add that bit in at the bottom. Okay, so we can change them either way. Alright, if you want to draw out the pictures, you can do so. Or if you want to use multiplying it out a bit, which is a little bit quicker, you can do so as well. It doesn't really matter which way you want to do, you just need to be able to do it. Okay, further down, we are going to look at something similar, but we're going to try and go the other way. So here we've got top-heavy fractions, and I want to change them to be mixed fractions. So looking at my first example here, I've got 10 thirds. So again, I'm just going to use my picture. I've got 1, 2, 3 of them there. So there's 1 hole. Okay, now remember, when you're doing 1 hole, the most it can have in it is the number that's on the bottom, because that is telling you how many bits you've cut your shape into. Cut it into 3. So there's me at 3 so far. Another 3. So I'm at 6 so far. Another 3 gets me to 9. I wanted 10, and so I only need 1 more, and that rectangle's got a nice wee curve in it. So I want that one. That brings me to 10. And so what I can see from here is I've got 1, 2, 3 holes, and I've got 1/3 left. Okay, I've got 1 out of 3 in that bottom shape. I'll look at the next example. We've got 17 over 5. So again, I'm cutting them into 5 bits. 1, 2, 3, 4, 5. So there's 5 of them. Getting some excellent shading. We'll do another one. 1, 2, 3, 4, 5. Okay, no one will punish you here if your shapes, your divisions aren't measured exactly to be the same size. Okay, as long as you understand that they are supposed to be, okay, you can manage to get along with this. So another 5 is 10. I want to get up to 17, so I've got 1, 2, 3, 4, 5. So chucking another 5 in there gets me up to 15. I'm almost there. I wanted 17, so I need 2 more. 1, 2, 3, 4, 5. So I'll take another 2, and that gets me to 17. And so from there, looking at my picture, I've got 1, 2, 3 hole, and I've got 2/5 left. Okay, now third example. In here deliberately, just to try and help prove a different method, we wanted to do 167 over 3. And we want to change it into a mixed fraction. That is going to take us a long time. Okay, because we saw over here in the first one, 3, 6, 9, 12, 15. We're going to be going up for ages. So instead what we can do is we can cheat a little bit. And we know what we are doing is we're trying to take our bits and divide them into little groups of 3. Okay, so here, I did 10 and I shared it into little groups of 3. There's a group of 3, there's a group of 3, there's a group of 3, and there's the one that's left. What we are actually doing when we ask you to do 10 over 3 is we are saying 10 divided by 3. Okay, remember that your division sign is just a little fraction. So when we do 10 divided by 3, we get 3, remainder 1. I don't know if we can see how those numbers start to link back in. If we did 17 divided by 5, we would get 3, remainder 2. And again, can we start to see where they are? If not, we're about to, because we're going to do it here. So we're going to do 167 divided by 3. So let's set it out. 1, 6, 7. How many 3's go into 1? They don't. How many 3's go into 16? I've got 5 with 1 left over. How many 3's go into 17? Again, 5. And this time I'm going to write my remainder. It's going to be one of the only times you're ever going to write your remainder. I know when we did our decimals, we'd have stuck our Z point in and we'd have kept going and we'd kept making it smaller, but here that's not what I want. What I was able to do is I was able to split 167 into 55 piles. And there were 2 left over, so my remainder 2 still needs to be divided by 3. That is my little shortcut method to save me having to draw all of those pictures.